This is part 3 of the study guide for the final exam. You need to recognize these as being sum and difference for sine and cosine. The sine of A plus or minus B is equal to sine A cosine B plus or minus cosine A sine B. And that's what's happening here. So you just need to simplify this. I look at, now there should be a parenthesis here because it looks kind of weird. But this sign is the middle sign. And it starts with sine. So this must be the sine of what plus what? Well, it's the 6x, which is the A, plus the negative 5x. Well, that just makes sine of x. And you're going to do the same thing here, except it's cosine. And you need to write your identity for sum and difference of cosine down. So cosine does cosine cosine. Cosine A, cosine B, minus plus. Remember, you got to change the sign in the middle. Sine A, sine B. So it starts with cosine. It's a cosine. It has a minus. You're going to put a plus. And then you're going to take this first A, which is negative 4 theta, and then negative theta, negative 4 theta, and negative theta make 5 theta, negative 5 thetas. And that's how you simplify those. Half angle identities, you need to write down the cosine one, the cosine half angle identity. So first thing you do is actually multiply this by 2. So this would be your theta, well actually we call it alpha. And you're going to multiply it by 2, and you're going to rewrite it as 330, which is 165 times 2, over 2. This becomes your alpha. And then the formula says for a half angle, well, it's the square root of 1 plus the cosine of alpha, so we're going to put 330 right there, over 2. Now, we need to know if it's plus or minus in front, and that's based off where the cosine of 165 is. So 165 is over here in this quadrant, and anything except for sine is negative. So we're going to sine and its reciprocal function, but sine, we know this is going to be negative. Now we're going to look back at our unit circle for what the cosine of 330 is. Cosine of 330 is root 3 over 2. So I'm going to replace that with 1 plus root 3 over 2 all over 2. And I'm going to get this top to be one fraction. So 1 can be written as 2 over 2. And so now I will just combine the tops to be 2 plus root 3 over 2. Just like you would with a fraction, if they have the same denominator, you keep the denominator and you just add the tops. And if you're dividing by 2, well, that's the same as keep, change, flip. Let's multiply by the reciprocal. So now I have negative square root of 2 plus root 3 times 1, which is 2 plus root 3, over 2 times 2, which is 4. And then you're almost done. There's nothing more you can do to the top, but you can take the square root of the bottom. So we're going to rewrite the top as the square root of 2 plus the square root of 3. And the square root of 4 is 2, and then we're just going to put that negative out in front. And that's the exact value. Now you have a calculator, you can put cosine 165 in your calculator, and then double check that this would be equal since it's a multiple choice test. So let's look real quick, making sure my calculator's on degree. So cosine 165 is equivalent to negative 0.965, and then we're just going to type in what we found as our exact. Negative square root of 2 plus square root 3. We're going to move it all over 2, and I get the same answer. All right, now solving some trig equations here again. These are a little bit more challenging than the other side, but if I see a squared sign and a 1, that's probably going to be a trinomial. So I'm going to get it all to this side. And I'm going to write it in a descending order. Sine squared first, then I'm going to minus the 2 sine theta over. And then I have the plus 1 equals 0. And I can factor this. Sine times sine makes sine squared. And 1 times 1. And they would both be minus. And then I would just set this equal to 0. So sine of theta minus 1 equals 0. Sine theta equals 1. Go around the unit circle. Sine is 1 at pi over 2, or 90 degrees. And that's the answer. Let's do this one. Again, I see a squared, I see a tan. I'm going to get it all to one side. Tan squared theta, I'm going to minus 2 tan theta, and then bring that over would be plus 1 equals 0. Very similar to what we have right here, except now it's tan theta minus 1 minus 1. And we really only have to set one of those equal. So tan theta equals 1. Again, that's on the back side of your unit circle. Tan is equal to 1 at the pi over 4. But there's another time tan can be not just pi over 4 right here, but across tan can be positive at 5 pi over 4. So we write both of them. And then we'll do this one. Now this one you need to actually either, try to think of an identity. So when I see cosine squared, I know that's equivalent to 1 minus sine squared. And then I have a minus sine squared from this third term, and then I have plus sine. And now I'm going to try to get this all to be on one side. And now I want negative sine squared to negative sine squared is negative 2 sine squared. So I'm going to bring it to that side and make it positive 2 sine squared. And then I'm going to minus the sine theta over, and I'm going to minus the 1. And again, this is factoring. So what two numbers multiply to negative 2 but add to a negative 1? And you would put sine theta, and it would be minus 2 and plus 1, multiply to negative 2, but add to a 1, and then because there's a 2 in front, we divide. And then setting each one of these equal to 0, you'd have sine theta minus 1, so we'll just say equals 1. And this one is sine theta equals negative 1/2. And then looking at your unit circle again, when is sine 1? That's at pi over 2. When is sine equal to negative 1/2 would be right there at 7 pi over 6 and 11 pi over 6. So 7 pi over 6, 11 pi over 6, and then this one is at pi over 2. So practice some of those. All right, now we're into conics. Identify the center and radius of each. Remember, this is your h and your k, and this is your radius, but it's being squared. So my hk, when I take it out of this standard version right here, I'm going to change the sign to 2, negative 3. So my center is at 2, negative 3. My radius is 2, because 2 squared is 4. So I'm going to go up 2, over 2, down 2, left 2. And there's my circle. Now, this one, you need to identify the center, vertices, co-vertices. So I already know this is an ellipse. I need to complete the square here. So the way you complete the square is you put all your x squared and then your x term, and then plus blank. Then you do your y squared and your 18y and plus blank. And then the minus 71 goes to the other side, becomes positive, and put plus blank, plus blank. Now you cannot complete the square if there's a number in front of x squared, so you're going to factor out the 16 16 factored from 64 is minus 4x. And then this one you have to factor out a 9. And we get y squared minus 2y plus blank. All right, now to complete the square, you take half the middle, which is negative 2, and you square it. And you put it here, but do not put it over here. You put 16 times 4 over there, which is 64. Do that again. You're going to take half the middle, negative 1. You're going to square it, which is 1. You're going to put 9 times 1, which is 9 right there. And then you rewrite this as 16 times. This can be rewritten as x, whatever you took a half of, minus 2, squared. This one is rewritten as 9 times whatever you took a half of, squared. And then just add up these. This is 80 plus 64, which is 144. And then you're almost done. Just divide by 144. And this reduces to 1/9. This reduces to 1/16, and this reduces to 1. And that's how you're going to write it. X minus 2 squared over 9 plus y minus 1 squared over 16 equals 1. That is the standard form. And now you can graph this ellipse. There would be a center at 2, 1. If you're under the x, you go the square root of that number left and right. So you're going to go 1, 2, 3 this way, 1, 2, 3 this way. If you're under the y, you go up and down. 1, 2, 3, 4. 1, 2, 3, 4. These are your vertices. If you're asked to find the eccentricity, remember eccentricity is found by the formula E equals C over A. And your C is found by the formula C squared equals A squared minus B squared. So it's just A squared, which is 16 minus 9. So C is 16 minus 9, which is 7, and then you take a, whoops, that's C squared. So square root of it, so square root of 7 over your A is the larger one. Take the square root of it, though, over 4. And it's about 0.661. Remember, it can't be over 1 if you're an ellipse. Now here, we're getting to hyperbolas. And hyperbolas go in the direction, if the y term comes first and is positive, then you're going to have hyperbola up and down. If the x term comes first, then you're going to have hyperbolas left and right. It doesn't matter which one's larger, it just matters which one comes first. So again, I first find the center, which again it's h, and then there's a k of 0. So there's a center at -1, 0. And then if you're under the y, you go up and down that many. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then left and right 4. 1, 2, 3, 4. You're going to draw a box. You're going to put diagonals through the box. And your hyperbola, since it's up and down, would be up here and right there. And these 2 points are the vertices. So there are vertices at -1, 5, and -1, -5. The foci are using the equation c squared equals a squared plus b squared. So different from the ellipse. The ellipse is minus. The foci for hyperbolas are plus. And a squared plus b squared, so it really doesn't matter. 25 plus 16, which is 41, and then you take a square root. And then you're going to add that to your center, again, your center, you don't need to know this, but it's good to write down, was at -1, 0. So you're going to add that since it's up down to the 0. So you're going to have foci at -1 plus or minus square root of 41. And then it asks us to find asymptote equations. To find asymptote equations, remember you set these two fractions equal to each other. So I'm just going to set y squared over 25 equals x plus 1 squared over 16. Don't worry about the negatives or anything. And then you're going to crisscross. You're going to get, well, actually, you just want to get y by itself, so let's just multiply by 25. My bad. Y squared equals, I like that 25 in front. And then take a square root. And you get y equals plus or minus, the square root of 25 sixteenths is 5/4. The square root of x plus 1 squared is x plus 1. And that's your asymptote equation. All right, let's do that again. Let's do it with the left, right. So this one's easy. This is at 0, 0. You're going to go up 5, 1, 2, 3, 4, 5, over 5, down 5. But you're not going to draw in a circle or an ellipse. You're going to draw a box. And you're going to make some diagonals. And since x is coming first, you're going to go right there and right there. And those 2 points right there are your vertices, which are at 5, 0 and -5, 0. And doing the same idea, the foci would be c squared equals 25 plus 25, which is 50. Square root of it, square root of 50 is a 5√2. And you're going to add that to the x's. So your foci would be at plus or minus 5√2, comma 0. And then your asymptotes would be at, I'm going to put the y squared term first, because it doesn't matter. I just like the y's on the left, equals x squared over 25. And if you multiply by 25, look at this. This one's a nice one. Y squared equals x squared. Take a square root plus or minus x. This line right here is the x line, and this one's the negative x line. So pretty easy. All right, one more page for this video. This one is identifying vertex, focus, axis of symmetry. So this is a parabola. So again, for a parabola, we want the vertex. I would write this on a note card, actually. If y equals x squared, your parabola looks like this, up or down, if it's negative. If it's x equals y squared, then it's right. So this one, x is being squared, so I know it's going to be up or down. That's positive. I know it's going to be up. This is my h, this is my k. When you bring it out, you change its sign. So there's a vertex at -2, 4. -2, 4. And then you are going to find your p and divide that. To find your p, divide that by 4. So divide that by 4 would be 1. So you're going to go up 1, down 1. And since I know that this is going up, that's my focus. And my focus is located then at -2, 5. This is a point on a line called a directrix. And a directrix line is always written as x equals or y equals. If it goes horizontally, horizontally is y equals. Y equals 2, 3. Oh, I went down too far, that's why. Whoops. This should be up there. My bad. Y equals 3. Yeah, I went down 2 spots. Should have gone down 1. And then your axis of symmetry goes right through them. And that's at x equals -2. All right, we'll do that again right here. Your h, your k, your vertex is at -1. -1. Again, if you find the vertex and know if it's up, down, left, or right, you're going to be halfway done. The y is being squared, so we know it's going to the right because this is positive. Divide by 4 is 1, so again, 1, 1. This is your focus. This one is your directrix line. So you have a focus at the point 0, -1. Your line of directrix is vertical, so it's x equals -2. And your axis of symmetry then would be the y equals -1 line. All right, determine if the sequence is arithmetic. If it is, find the common difference, the 52nd term, and the explicit formula. So this, to go from 26 to a -4, you'd have to subtract 30. And you keep doing that every time. So this is arithmetic. So we're going to use the formula AN equals A1 plus N minus 1 times D. Put that on your note card. Your AN, the A1 is the first term, which is 26, N minus 1, and your common difference is -30. Distributing that would be 26 minus 30N plus 30. So then my formula would be -30N plus 56. Now when I go to find the 52nd term, I just plug 52 right there. So -30 times 52 and then plus 56. 52nd term is following -1,504. Evaluate the series. Now again, you need to know your series formulas. This has an AN and an A1. So the series formula is S sub n equals N times A1 plus AN divided by 2. They told us N was 8. A1 is -31. AN is -73. And I'll just let my calculator do all that work for me. Divide that by 2, and then multiply that by 8. -416 is the answer. One more part, and we are done.